So today's topic for mobile communication, reverse CDMA channel. Myself, Dr. R.R.Dube, working as Professor Electronics and Telecommunication Engineering Department. Last time we have studied the forward CDMA channel. So today, at the end of this session, the student will be able to explain the concept of reverse CDMA channel. Now, reverse CDMA channel, the user data are grouped into 20 RNS frames. So, all the data transmitted on the reverse channel are convolutionally encoded, block interleaved, modulated by 64 array orthogonal modulation and spread prior to the transmission. There are various speeds associated for the user data rate for the reverse channel that can be sent at 9600, 4800, 2400 or 1200 bps. There are various characteristics, all the parameters associated for the reverse CDMA channel. One, it is defined at, just we have seen with the various rate from 9600 to 1200. They are defining with respect to code rate, the duty cycle, and the data rate, bit per wall symbol, as well as the rate associated for this bits per wall symbol, the rate which is almost constant for all the data rate. Likewise, all the parameters including the PN chips per code symbol, PN chips per wall symbol, and PN chips per wall chip with the data rate, various data rate provided for reverse CDMA channel. Now, this is the block diagram of the reverse IS95 channel modulation process. The first, it is the convolution and the encoder and the repetition with R is equal to 1 by 3, K is equal to 9, and it is provided, just we have seen, with the various rate 1200 to 9600 bps. So, this convolutional encoder provides the code symbol which is block interleaved and which is modulated with the 64 array orthogonal modulator with the speed associated as 28.8 kbps. The data burst randomizer is also included while considering with the along the PN chip with the rate 1.2288 MCPS as the long code generator, and these two signals has been added and further provided to make the separate out with the two separate channels. One, it is sequence I channel and the other is the sequence Q channel. At the last, the baseband filter has been introduced to remove the interference or the noise, and we can get the symbol, a particular symbol with respect to the PN sequence associated as I of T and Q of T. The reverse channels, CDMA channels, are made up of, just we have seen in the last PPT, are made up of access channels as well as the reverse traffic channels. Both share the same frequency assignment, and each traffic or the access channel is identified by a long code. The access channel is used by the mobile to initiate the communication with the base station and to respond to the paging channel messages. Channel in a random process with each channel user uniquely identified by that long code. The reverse CDMA channel may contain maximum of 32 ACs per supported paging channels, while RTC operates at a variable data rate with the fixed data rate, it is 4800 bps. In addition, we are having the convolution coder used in the reverse traffic channel is rate 113 and having the length 9. The three generators use as G1, G2, which is 557 octal, 663 octal and 77 octal respectively. The coded bits after convolution encoder are repeated before interleaving when the data rate is less than 9600 bps. The interleaving method is carried out to make the adjustment of the data rate, it is equal to the 9600, which is identical to the method based on the forward channel. After repetition, the symbol rate out of the encoder, it is fixed at 28800, is performed by using the convolution, encoding and the repetition. The block interleaver spans with the period 20 millisecond and it is an array of 32 rows and 18 columns, and the code symbols are written in that matrix by columns and read out by the rows. Modulation process has been carried out by the method of 64 array orthogonal modulation used for reverse CDMA channel. One of 64 possible Waltz function is transmitted for each group of 6 coded bit. Within a Waltz function, 64 Waltz chips are transmitted. Particular Waltz function number, it is defined as C0 plus 2C1 plus 4C2 plus 8C3 plus 16C4 and plus 32C5. C5 represents the last coded bit and C0 represents the first coded bit of each group of 6 coded symbols that has been selected for the Waltz function. Waltz chips are transmitted at the rate 307.2 kcps as shown in the equation, with 28.8 encoded with 6 coded bits is equal to 307.2. The Waltz function are used for different purposes on the forward as well as reverse channels. There is variable data rate transmission available on the reverse CDMA channel. The code symbol repetition introduces redundancy when the data rate is less than 9600 bps. When the data rate is 9600 bps, all interleaver output are transmitted. When the data rate is 4800, half the interleaver output bits are transmitted and the mobile unit does not transmit 50% of that time. Data in each 20 millisecond frame are divided into 16 power control groups, each with the period of 1.25 millisecond. Some power control groups are gated on while others are gated off, and data bus randomizer ensures that every repeated code symbol are transmitted exactly once. During the gate off process, the mobile station reduces its EIRP either by at least 20 dB with respect to the power of the most recent gated on period or to the transmitter noise floor, whichever is the greater. So that is a minimum condition that has been defined for the gate off processes that reduces the interference to other mobile stations operating on the same reverse CDMA channel. Data bus randomizer generates patterns, zeros and ones, that randomly mask the redundant data generated by the code repetition process. The 14 bits, that is starting from B0 to B13, are used for spreading the second to the last power control group of the previous frame to determine the random mask for the gating. B0 represents the earliest bit and B13 represents the latest bit. If the user data rate is 4800 bps, the transmission occurs on 8 power control groups given as B0, 2 plus B1, 4 plus B2, so on, 14 plus B7. If the user data rate is 240 bps, the transmission occurs on the 4 control groups that has been shown. B0 if B8 is equal to 0, or 2 plus B1 if B8 is equal to 1, so on. For the data rate is 120 bps, the transmission occurs on the 2 power control groups has been numbered, has been shown here. There is one more procedure has been adopted in reverse CDMA channel, direct sequence spreading. The reverse traffic channel is spread by the long code PN sequence, which operates at the rate 1.2 to 88 MCPS. Each Walsh chip is spread by 4 long code PN chips. There is again a modulation technique, it is available, a coordination modulation technique, or a reverse link modulation, or it is a phase shift keying is adopted to show the reverse CDMA channel. Data spread by this Q pilot PN sequence, it is delayed by half with respect to the data spread by the I pilot PN sequence. This delay is used for improvement in the spectral shaping and synchronization. The references has been shown.